Hi, my name is Dr. Edna Fernandez. I am a postdoctoral research fellow in Dr. Stephanie Rogers' GeoIdea Lab at Auburn University, and I will be co-mentoring Callista this summer. I'm really happy that you guys are here. Unfortunately, I am in Grand Rapids, Michigan at a scientific conference, so I cannot join you. But I will be telling you a little bit about my research before I came to Auburn, because I want y'all to know in case you're interested in any of these things, so you can reach out to me and ask me for some honest feedback. And then I'm going to tell you a little bit about one of my research projects as a PhD student. So before I came to Auburn, I was an undergrad at Eckerd College, where I did a bachelor's in marine science and environmental studies. Eckerd was awesome, but it was a liberal arts school, so there wasn't a lot of research. So my sophomore year, I went to Western Washington University, where I was in a program called MIMSUP, which is essentially just a semester-long REU. And this was my first introduction to formal research. And if I could give you all a single piece of advice before you start your REU, it's that you have to be very, very self-motivated this summer. You have to be excited about your question, and you need to want to find out more and ask questions to your advisor and look up information on the internet and go on YouTube and try to understand it backwards and forwards, because that's the way that you're going to get the most out of this experience. Okay. Um, After I was done with my RU, I did a few different things. So a lot of my time was focused on coral restoration efforts, and I did this through the Nature Conservancy in the Virgin Islands, through the University of Puerto Rico, and then through the Coral Restoration Foundation in the Florida Keys. I also taught marine science and windsurfing at Sea Camp, which is in the Florida Keys, and I also worked as a water quality technician for Rookery Bay National Estuarine Research Reserve before I came to Auburn. So when I came to Auburn, I was really interested in harmful algal bloom ecology. I was in Dr. Alan Wilson's limnology lab, and this is his bread and butter. So in particular, I want to talk about a project in which I was trying to figure out how much cyanobacteria was in the water relative to plankton using drones. The reason we care about this is because phytoplankton, commonly known as algae, are the base of aquatic food webs. And in healthy systems, we're going to find a bunch of different types of phytoplankton in the water, like green algae and diatoms and cyanobacteria. But when we get too much nutrients getting into the water due to agricultural fertilizers or industrial runoff, this can feed the phytoplankton in the water, and in particularly, they can allow cyanobacteria to outcompete all the other phytoplankton and grow uncontrollably. So we don't want this because cyanobacteria can produce taste and odor compounds that can make drinking water taste and smell really bad. And they can also produce cyanotoxins, which can make aquatic organisms, pets, livestock, and even us really sick. So I wanted to do a project where we use drones to differentiate between ponds that were dominated by phytoplankton in general, which are good because they're feeding our critters like Daphnia, and ponds that were green because they had a lot of cyanobacteria, which is really detrimental. So the first set of data that I collected was done with Catherine Cruz, who was the RE student that I mentored in 2019. So this is the project that we did. So when we started, we didn't even know which drone sensor worked for monitoring aquatic ecosystems, and in particular harmful algal blooms. So we compared 4 different drones. We have 2 of these Phantom 4 series visible light spectrum drones. So the pictures from this drone are going to look like what you get from a regular camera. And then we had 2 multispectral drones, and these are able to monitor the near infrared wavelength, which is really important for monitoring photosynthetic activity. So we took these 4 sensors and we took a bunch of pictures of a bunch of different kinds of ponds. We took ponds of different sizes, ponds at different times of the year, and more importantly, ponds of different concentrations of phytoplankton and cyanobacteria, as well as ponds that were really muddy like these ones and ponds that were clear. So basically all kinds of ponds. And what we found was that this drone was the best one for monitoring harmful algal blooms, and it was really good at estimating how much phytoplankton in general was in the water, so that all the organisms that can do photosynthesis, it was really good at estimating them. So here we have chlorophyll, which is an estimate of how much phytoplankton is in the water, and then a vegetation index, which is the calculation we do to understand how much photosynthetic activity is in that area. And you can see it's a really, really good relationship. But the drone wasn't as good as estimating how much cyanobacteria specifically is in the water. And this is because cyanobacteria have a special pigment called phycocyanin, which is here on the x-axis. And the drone isn't really good at picking up that pigment because it absorbs light right here in this section of the electromagnetic spectrum. Oh, you might not be able to see that. This region of the electromagnetic spectrum, and none of the drones are able to measure that. So if you actually want to learn more about this project, I know that was really fast. I have a talk on this paper on YouTube. It's called Best Drone for Monitoring Harmful Algal Blooms. So go check it out. And if you have any questions, please feel free to email me. Thanks. Bye.